In this project, we use reinforcement learning to solve the traveling salesman problem. Our first approach uses a policy-based staging. Suppose we're given a graph, which is a sequence of points in R2. We have a complete graph where the distance between the nodes is the Euclidean distance. Our model is an LSTM encoder-decoder with an attention mechanism. The initial states of the LSTM are the zero vectors. The input is passed through a linear map to embed it into 128 dimensions. It's passed into an LSTM with the previous hidden and cell state to produce the next hidden and cell state. Our decoder LSTM generates a new tour, and this tour should be a permutation of G and not just random points in R2. For this, we use a pointer network. Our decoder LSTM uses the initial states coming from the final states of the encoder. The initial input is a learnable vector, and the initial output is K1. We calculate the attention score using K1 and calculate the similarity score with the encoder hidden states. We apply a masked softmax to prevent revisiting nodes. Sample this probability, and in this example we sample the index 2, so we visit node 2, and the next input into the LSTM is the second hidden state from the encoder. This is the formula we use to calculate the similarity score. W1, W2, V are learnable parameters. We use exponential moving average as the baseline, but we also use a critic. And the architecture of the critic is an LSTM followed by a two-layer neural network with Gradle activations. This is what a typical graph looks like. Every 1,000 episodes we generate a new batch to train on, hence the drop in reward. But overall, the trend is that the model gets better and better, and the drops get less severe, suggesting that the model is generalizing well.
As a means of comparison, we also wanted to implement a value-based method. So to that end, we decided to use Q-learning with an epsilon greedy policy to predict and update the Q values. For the prediction of these Q values, we decided to use a deep neural network. At first, none of our models were really able to learn the complex environment of the traveling salesman problem, until eventually we implemented an edge-based graph neural network. This neural network uses nodes to mimic the cities and learns how the messages are passed between the nodes using multi-layer perceptrons. So basically each edge is a multi-layer perceptron with one hidden layer. This was crucial for the traveling salesman problem because it made it possible for the model to learn about the distances between the nodes. So we fine-tuned and tested this model, and the model with a decaying epsilon and replay buffer turned out to be consistently more performant than a greedy algorithm and was very close to the heuristic Python solver, so it was very performant. So yeah, to recap, we wanted to use reinforcement learning to solve the traveling salesman problem, which is an NP-hard combinatorial problem. We used both policy and value-based methods, both of which were able to learn very well the problem and output good solutions for the problem.